Witnesses in Colombia observed the object gliding with purpose until it struck high-voltage power lines and dropped to the ground. What they recovered wasn't just unusual, it was unlike anything we've ever seen.
The sphere was flying all around this little town down in Colombia. He said, I want you to look at it, and then I'm going to call you right back. So I said, all right. So I go to the phone, and there it is, flying all around this little town, right?
In a small laboratory in Colombia, a discovery has sent ripples through the scientific community. José Luis Velázquez, a renowned researcher in advanced materials and unexplained phenomena, recently opened what is now being called the Buga Sphere for the very first time. This mysterious metallic orb, discovered decades ago, buried in the outskirts of Buga, had remained sealed and untouched because of its unusual composition and enigmatic origin.
To present initial scientific findings surrounding the object now known as the Buga Sphere, a mysterious flying sphere recovered in the town of Buga, Colombia.
Many dismissed it as a relic or a curiosity, but recent technological advances allowed Velázquez and his team to finally examine it in detail. What they found inside is disturbing. The sphere contains material unlike anything cataloged in scientific databases. Shapes that seem artificially arranged, substances that resist conventional analysis, and patterns that suggest intelligence rather than random formation. From its magnetic anomalies to its internal geometry, the Buga Sphere challenges our understanding of physics, materials science, and perhaps even the origins of life itself. Today we will explore astonishing aspects of the Buga Sphere, uncovering the discoveries Velázquez made, the implications for science, and the questions that remain unanswered. Each revelation raises more mysteries, and by the end of this exploration, it will be clear that this object is not simply a curiosity. It is a puzzle that has confounded experts and may forever change our understanding of what is possible. The discovery of the Buga Sphere was first discovered in the early 1970s by local farmers excavating soil near Buga, Colombia. Its metallic surface was unusually smooth, perfectly spherical, and surprisingly heavy for its size. Early attempts to cut or scratch the sphere failed, as it resisted conventional tools. Scientists at the time had limited technology to analyze the material, and many concluded that it was either a natural metallic formation or an unexplained artifact from an unknown civilization. The sphere remained untouched for decades, stored in a local museum under strict supervision. Its origin remained a mystery, and rumors about its properties grew over the years. Velázquez, intrigued by reports of internal structures detectable through advanced imaging techniques, petitioned to study the sphere using modern scientific equipment. His goal was to finally answer questions that had baffled researchers for nearly 50 years. What is inside the sphere, and how did it come to exist in a form so precise that it seems almost impossible to occur naturally? The sphere's outer material, upon initial examination, Velázquez noted that the outer shell of the Buga Sphere was composed of a metallic alloy unlike anything known in conventional metallurgy. Spectroscopic analysis revealed an unusual mix of elements that typically do not combine under natural conditions. Additionally, the metal displayed a high resistance to temperature changes and corrosion, suggesting it had been engineered rather than formed through geological processes. The surface of the sphere was polished to a degree that would require highly advanced techniques, possibly unknown even to modern engineers. Microscopic analysis showed patterns etched into the metal that were not visible to the naked eye. Geometric designs that appeared to be deliberately structured. This outer material alone presented a puzzle, as no known natural or human-made process could explain the combination of strength, composition, and precision. Velázquez emphasized that the metal's stability and hardness could potentially allow it to survive extreme conditions, including high energy impacts, temperature extremes, and chemical exposure, which may explain its preservation over decades underground. Magnetic anomalies detected. One of the first surprising discoveries Velázquez made involved the sphere's magnetic properties. Using sensitive magnetometers, his team detected fluctuating magnetic fields around the sphere that did not correspond to the Earth's natural magnetism. These anomalies appeared to be concentrated in specific areas of the sphere, suggesting that the internal material might be organized in a way that generates a magnetic field. The magnetic fluctuations were unpredictable yet measurable, leading the team to consider possibilities beyond conventional science. Could the internal arrangement of material create a self-sustaining field? Or was it designed to interact with external forces in ways unknown to physics? The magnetic behavior immediately raised questions about the sphere's purpose. Velázquez noted that while many metals exhibit magnetism, the patterns observed were unique, neither resembling natural minerals nor conventional technological applications. These anomalies would later guide the team's decisions when opening the sphere, as careful handling was necessary to avoid interference with the magnetic activity. Imaging the interior before opening the sphere, Velázquez employed advanced imaging techniques, including high-resolution X-ray tomography and neutron scanning. These non-invasive methods allowed the team to peer inside without physically breaching the metallic shell. What they saw shocked them. The interior contained intricate, interconnected structures resembling networks, tunnels, and chambers, some of which were perfectly symmetrical. Certain cavities contained tiny crystalline formations that emitted faint energy signatures detectable by sensitive instruments. The interior design seemed almost architectural, as if the sphere were constructed with a deliberate plan rather than resulting from natural formation. These preliminary scans confirmed what the team suspected: the sphere was far from a simple metallic object. The interior complexity suggested an advanced level of engineering, and even the imaging process raised more questions than it answered, such as the purpose of the energy emitting crystalline clusters and the significance of the symmetrical structures. Opening the sphere after months of careful planning, Velázquez and his team began the delicate process of opening the Buga Sphere. Specialized tools were used to avoid damaging either the outer shell or the internal structures. The procedure was slow, meticulous, and conducted under controlled environmental conditions. As the first layer was removed, the team observed that the interior maintained structural integrity despite decades underground. Dust and soil from the surrounding excavation had been almost entirely blocked by the sphere's unique properties, preserving internal structures with astonishing precision. Opening the sphere marked a turning point, transitioning the investigation from observation to direct analysis. What was found inside immediately validated the suspicions raised by imaging. The Buga Sphere was more than a metallic curiosity. It was a vessel containing an arrangement of materials that defied conventional understanding. Strange crystalline formations inside the sphere, Velázquez discovered crystalline structures unlike any naturally occurring minerals. These formations exhibited symmetry at multiple scales and appeared to interact with each other through energy fields detectable only by sensitive instruments. Unlike traditional crystals that grow randomly or according to geological pressures, these formations were organized with a purpose, forming lattice-like networks throughout the interior. Some crystals emitted low-level radiation or energy pulses, though not in harmful amounts. The structures seemed to serve both as supports and possibly as conduits, suggesting that the sphere was not inert but had been designed to channel or store energy. Velázquez noted that these crystalline networks resembled artificial constructs used in advanced technologies, though no known material or engineering process could replicate them. The presence of such formations immediately raised the question: if artificial, who could have created them and for what purpose? organic-looking components inside the Buga Sphere, José Luis Velázquez discovered structures that appeared organic in nature, though they were clearly not alive in the biological sense. These components exhibited patterns resembling cellular or vascular networks with segmented channels and tubular formations running throughout the interior. Chemical analysis revealed a combination of carbon, silicon, and trace elements that typically associate with organic compounds, yet the material was unnaturally stable and resistant to degradation. The arrangement of these organic-looking structures was deliberate, forming a complex internal architecture that integrated seamlessly with the surrounding crystalline formations. Velázquez suggested that these could serve as conduits for energy, perhaps designed to interact with the crystalline networks or act as storage matrices. What makes this discovery extraordinary is the precision with which these organic-like components were engineered. Natural processes rarely produce such consistent symmetry across multiple layers of material. The findings blur the boundary between biology and technology, implying that the creators of the sphere may have utilized biomimetic principles or entirely unknown engineering methods. These organic-looking structures challenge conventional understanding and raise profound questions. Were they designed to perform a function, to record information, or simply to maintain stability? The implications extend beyond metallurgy and materials science, touching on biology, energy physics, and even the philosophy of artificial life. For Velázquez, this discovery confirmed that the sphere was more than an inert artifact. It was a complex, multifunctional system that could encode unknown forms of information or energy within its internal architecture. Evidence of energy conduction, one of the most startling revelations inside the Buga Sphere, was its apparent ability to conduct energy in ways that defy modern understanding. Velázquez and his team observed that the crystalline and tubular components acted as pathways for energy transmission, responding to electromagnetic stimuli with precise, patterned behavior. These conduits did not resemble conventional circuits. There were no wires, chips, or recognizable electronic components, yet energy flowed through them in a controlled and efficient manner. Even more puzzling was the sphere's apparent capacity to store and release energy without visible degradation or heating of its components. Tests revealed that the sphere could interact with external electromagnetic fields, suggesting that it might have been designed to operate as a receiver, transmitter, or energy storage device. This discovery raises questions about the level of technological sophistication required to engineer such a system. Could this object be centuries or millennia ahead of current human capabilities? Velázquez noted that the energy conduction patterns were consistent with intelligent design, reinforcing the notion that the sphere's creators possessed knowledge of advanced physics far beyond modern science. The controlled movement of energy, combined with the crystalline and organic-like internal structures, points toward a device designed for a specific, yet currently unknown, purpose, possibly related to energy storage, signal transmission, or another function not yet conceptualized by contemporary researchers. Anomalous radiation signatures. As analysis continued, the Buga Sphere exhibited subtle yet persistent radiation signatures. These emissions included low-level electromagnetic pulses and faint infrared signals, which were inconsistent with ordinary metallic objects or natural crystals. The radiation patterns were irregular but continuous, suggesting that the sphere retained internal energy or activity despite remaining buried for decades. Velázquez emphasized that while the radiation was not harmful, it indicated a level of functionality that defies conventional explanation. The patterns did not correspond to known satellite emissions, cosmic radiation, or environmental background signals. Some areas of the sphere produced stronger readings, aligning with the organic-like components and crystalline networks, hinting at interaction between different internal systems. These radiation signatures prompted the team to take extreme caution during further examination, as the sphere's response to external electromagnetic fields remained unpredictable. The presence of radiation not only confirmed that the sphere was more than a passive artifact, but also suggested that it may have been designed to interact with energy. The potential implications are profound, as understanding these emissions could unlock insights into energy storage, transmission, or even unknown forms of communication, pointing toward advanced technological principles lost or undiscovered in modern science. Symmetry and structural alignment. Detailed inspection revealed that the Buga Sphere's interior is meticulously aligned, both radially and along multiple axes. Crystalline networks, tubular formations, and cavities all follow a deliberate geometric pattern, suggesting an intentional design. Velázquez observed that these symmetrical alignments corresponded with magnetic anomalies detected around the sphere, indicating that the structure may have been engineered to optimize interactions with energy fields. The level of precision is extraordinary. No natural process known today could create such a highly ordered arrangement with consistent symmetry across multiple layers of material. This internal architecture hints at functional design rather than purely aesthetic or random formation. The symmetry extends to even the smallest microstructures within the sphere, reinforcing the idea that every component serves a specific purpose. Velázquez noted that understanding these patterns is key to deciphering the sphere's functionality, as the alignment likely governs energy conduction, radiation emission, and structural stability. In essence, the sphere appears to be a unified system where form and function are inseparable, reflecting a level of engineering sophistication that challenges modern scientific understanding. Signs of manipulated gravity or magnetic effects. Another intriguing discovery involved subtle gravitational or magnetic interactions associated with the sphere. Velázquez detected small perturbations in nearby magnetic fields when the sphere was moved or rotated. These anomalies did not align with standard magnetic behavior, suggesting that the sphere might manipulate or influence magnetic forces internally or externally. While the effects were slight, they were measurable using sensitive instruments, and they persisted even after long periods of inactivity. Some theories suggest that the internal crystalline networks, or organic, like conduits, could be generating localized magnetic fields. These findings imply a design that considers not just material composition, but also dynamic interaction with environmental forces, which is unprecedented in conventional metallurgy or engineering. Velázquez emphasized that these effects warrant further study, as they could hint at principles of energy manipulation, propulsion, or force control unknown to modern science. Potential historical implications. The sphere's advanced construction and unique material composition raise questions about its origin and historical significance. If the Buga Sphere is indeed an artificial creation, it may belong to an unknown civilization with technological capabilities far exceeding anything documented in human history. Velázquez speculated that it could have been buried intentionally, perhaps as a form of preservation, a time capsule, or even a device for future discovery. Its survival underground for decades with minimal degradation suggests advanced knowledge of material stability and environmental interaction. The sphere challenges conventional timelines of technological advancement, prompting historians, archaeologists, and scientists to consider possibilities that bridge ancient craftsmanship, advanced engineering, and unknown scientific principles. The implications extend beyond Colombia. If similar artifacts exist elsewhere, our understanding of technological history may require dramatic revision. Internal microstructures and network complexity. Inside the Buga Sphere, Velázquez discovered a network of microstructures that are astonishing in both complexity and precision. These microscopic formations form interconnected lattices, tubular channels, and minuscule cavities that are organized in a pattern too deliberate to be natural. Each component interacts seamlessly with surrounding crystalline and organic-looking structures, suggesting a functional design rather than random formation. Advanced imaging revealed that the microstructures may serve multiple purposes, potentially acting as conduits for energy, storing information, or stabilizing the internal framework. Some patterns resemble fractal geometry, where smaller repeating structures mirror the larger organization, hinting at principles of design that optimize both space and function. The intricacy of these networks challenges conventional understanding of material science, as even the tiniest structures display precision beyond what current technology can replicate. Velázquez suggested that studying these microstructures could provide insights into engineering methods far beyond modern capabilities, as the internal complexity points toward knowledge of material manipulation, energy management, and perhaps even quantum-level construction. This revelation underscores that the Buga Sphere is not just a static artifact. It is a sophisticated system whose internal architecture was designed with purpose, precision, and perhaps intelligence. Interaction between components. Velázquez observed that the different internal components of the sphere, the crystals, organic-like structures, and micro-networks, interact in ways that suggest a coordinated system. For instance, electromagnetic tests showed that energy introduced at one point would propagate through specific pathways, activating multiple structures along the way. The crystalline networks appeared to amplify or guide energy, while the organic, like conduits, acted as channels or buffers, controlling the flow and distribution. Even the microstructures participated in this network, maintaining stability and possibly regulating energy transmission. This level of coordinated interaction implies that the sphere was engineered to function as a unified whole rather than a collection of random components. Understanding these interactions is crucial for determining the sphere's purpose. Velázquez emphasized that these observations point toward a level of engineering sophistication that is extraordinary, potentially combining principles of energy storage, signal processing, and structural optimization in a single object. Unexplained resonances. During testing, Velázquez discovered that the sphere exhibits resonances when exposed to various electromagnetic frequencies. These resonances are not consistent with ordinary metals, crystals, or known alloys, indicating a unique internal response. Some resonances were harmonic, repeating at specific intervals, while others were erratic yet measurable. Remarkably, certain frequencies caused energy to propagate more efficiently through the internal networks, suggesting a potential design for energy manipulation or communication. The team hypothesized that these resonances could have been intended to interact with natural environmental forces such as magnetic fields or even cosmic radiation. Understanding these resonances is critical because they may reveal the functional purpose of the sphere, as well as the level of knowledge possessed by its creators. These properties hint at technology or design principles not yet understood, raising profound questions about the sphere's origin and intent. Signs of potential data storage. One of the most compelling discoveries was the possibility that the Buga Sphere may have been used to store information. Velázquez and his team noted that the patterns in crystalline and organic-like structures are consistent with methods of encoding data at micro and nano scales. The internal arrangement, symmetry, and network interactions suggest that energy or other stimuli could trigger specific responses analogous to writing and reading information. While no traditional code was found, the systematic organization indicates a high probability of functional storage. If true, this means the sphere could contain knowledge, instructions, or data from an unknown source preserved with exceptional stability over decades or even centuries. This potential transforms the sphere from a mere artifact into a repository of intelligence, making it one of the most enigmatic objects ever examined. Theories about the origin of the Buga Sphere remains hotly debated. Velázquez considered multiple possibilities, including natural formation, ancient human craftsmanship, extraterrestrial engineering, or even advanced temporal technology. Natural formation is unlikely due to the precision of the internal structures and the unusual composition. Ancient human origin also seems improbable, as no known civilization could produce materials, microstructures, and energy conducting networks of this sophistication. Extraterrestrial origin is a popular hypothesis, especially considering the energy properties, resonances, and organizational complexity. Regardless of its source, the sphere challenges historical and technological assumptions, suggesting that either human knowledge was once more advanced than believed, or that it is the product of an entirely unknown intelligence. The origin remains one of the greatest mysteries surrounding this artifact. Potential implications for science. The discoveries within the Buga Sphere have far-reaching implications. If the sphere is artificially constructed, it could revolutionize materials science, energy transmission, and even information storage. Velázquez suggested that understanding its energy conduction, resonances, and internal architecture could inform new technologies and inspire scientific breakthroughs. Beyond practical applications, the sphere forces a reevaluation of history, archaeology, and physics, challenging long-held assumptions about what is possible. Its existence reminds scientists that there are phenomena in our world and universe that remain unexplored, awaiting careful observation and analysis. The Buga Sphere is not merely an artifact. It is a doorway to understanding principles and technologies that could reshape human knowledge. The Buga Sphere, opened by José Luis Velázquez, is more than a scientific curiosity. It is a profound mystery that challenges everything we know about materials, energy, and intelligence. From its complex internal networks to its anomalous magnetic and energy conducting properties, every discovery raises more questions than answers. The possibility of data storage, resonances, and advanced construction suggests a level of sophistication that surpasses modern technology, hinting at an origin that may be ancient, extraterrestrial, or otherwise unknown. The sphere's existence encourages humanity to look beyond conventional understanding and embrace the unknown, reminding us that even in our modern age, mysteries endure. As Velázquez continues to study this extraordinary object, the world watches in anticipation, waiting to see whether the Buga Sphere will reveal secrets that could transform science, history, and our understanding of the universe.